So my summary output, I'm going to find the value for R, 5936, same value we got a while ago. R squared is going to be the variance accounted for. So we can account for all the variables there. And when I square R, I'll get this value and it'll give you that value. Adjusted R is going to be some standard error, and it's going to be an adjusted R value. And then we've got the standard error of the estimate, which I'm not real concerned about. And we've got 10 pairs that we have observed. So all that looks good. I'm not going to mess around with the ANOVA table right now. We'll learn about that in the weeks coming up. However, I want you to be able to read this. Here's the intercept, 2.9 or 29.27. 29.36, that's real close by hand, close enough. And this value here is the x variable, and we're going to call that the slope, whatever that x variable slope is, and it's 3.245. So 3.24, I'm darn close by hand. So I can do this by hand, but I don't have to. You just have to be able to know where to find the stuff. This is the intercept, and that's the slope. You don't have to do it by hand. I just wanted to show you how to do it by hand. This is pretty impressive too. If we look at p-values, and a p-value is a probability for making a type 1 error. So if the confidence in my output is 95%, then there's 5% error, or my alpha level is 5%. So there's 5% chance of making a type 1 error. So if we take a look at some of these p-values, there's no significance here, because I've got 0.2, which is 26% on my intercept, and I got 0.7, which is 7%, so I don't have significant differences in those two variables. And that's one way to do this. So my R value would have to be a lot bigger than just 0.59. It would have to be, like 0.7 or something like that. And then I may find some significant differences here in those p-values. But this is just a good way of doing that. Now, let me show you how to actually make a prediction. I want to predict a value of X. So let's say that I'm looking at this data and I say, well, what about, man, I don't want to put in 17 hours of study time. What would 10 hours get me? So X is going to be equal to 10. And now I can, since 10 is not in here, I can predict some value that my grade would be if I studied 10 hours a week in this hypothetical situation. I would use this particular formula right here in order to do that. So my predicted value of Y is going to be equal to my intercept, which is 29.36, plus my slope, which is 3.24 times 10. So let's do that and see what we get. So I might be a gambling person, and I say, man, I only want to study 10 hours a week. I want to put 17 hours in. So now I'm going to put 10 hours in. So first thing I got to do is this. I got to do 10 times 3.24. 3.24. That gives me 32.4. Now, here's a nice, neat thing, is we just put 29.36 plus 32.4, that'll give us our grade, which is a 61.7 or a 62, rounded up to a 62% for your final grade. Not very good. So I would probably go, well, based on these data and the outcome of this, my predicted value of Y on my grade, I don't want a 62, so I need to study more. So if I study 15 hours, so what would my grade be for 15 hours? So I do all this with 15. So I got 3.24 times 15 instead of 10. So I'll do that real quick and show you the difference. So 3.24 times 15 is 48.6 So now I got something good. 29.36 plus 48.6, which is a lot better because that's almost a B. I've raised it to a 77.96 or a 78%. Much better than a D at 62 and almost an F. So this is how you would use regression analysis to make predictions based on two variables. Now, I'm going to show you something really cool, and hopefully this will help you do all the homework. So looks like it's coming back to life. So I'm going to show you how to do the scatter plot. And it's really easy, really easy. So I got all these outputs and inputs and all that stuff. So I'm going to come over here. I'm going to go ahead and highlight my data. That's the first thing I'm going to do. And then I'm going to go up here to input, and then I'm going to find my graphs, charts, and I'm going to choose this one right here. In the middle it says scatter X and Y or bubble chart. Well, I'm going to go ahead and click on that, and it's going to open it up. There's a scatter plot there. I just want some more options, see what's out there. Oh boy, there it is. That's the one I want. So I'm going to go ahead and highlight that and click OK. There it is. I can see that this is a positive correlation because as this variable goes up, this one's going up, and it shows us exactly where all these data are. So for a point of data that looks like 59 on our y-axis, so we can see that 59 is going to be correlated with about 12. So that one's right there. So it shows us what the correlation is. It's a nice, pretty tight little group, about 60% of the variance is shared. And just a nice way to look at things. It'll tell you if it's a positive correlation. If it was moving in this direction, it would be a negative correlation. Or if it's just scattered and you can't really see a direction that the two variables are traveling in, that would be no correlation whatsoever. So I'd like for you to report that on your homework as well. And it's real easy, like to print that out or to get an image of it. You just go to File and go down to Print, wherever Print is. There it is. It's hard to see sideways here. And you click on Print, and that's what would be printed out there. So it's pretty neat, and you can just save that and then attach it to your homework. No problem whatsoever. So hopefully this will help you with your homework. It's not real difficult. It's just hard when you're reading the book or looking at the PowerPoints to try to understand this information. And I don't want to go into too much detail with covariance and R squared and adjusted R. For this class, I just want you to understand what those correlations are and how you can make predictions of some value of Y based on a value of X. All right, have a good weekend, and I'll continue to get things graded. Looks like I've got everything graded so far, with just an exception of a few things that haven't been turned in. So have a good weekend, and I'll be in touch next week. Thank you.